These are some of my favorite problems because it ends up turning into Calc 1 or stuff you did earlier in the year, last year. So, for reasons unknown, which hopefully we'll figure out in a second, is we need to figure out these three values, the f of 2, f prime of 2, and the second derivative at 2. So, t of 2 is going to be the same thing as f of 2. Because when I plug in 2 to all these things, this goes to 0, that goes to 0, that goes to 0, I'm just left with 1. I then want to take the derivative, so t prime of x is going to be negative 10 x minus 2 plus 9 x minus 2 squared minus 24 x minus 2 cubed. I plug in 2. Because t prime of 2 and f prime of 2 are going to be the same. I plug into all these terms go to 0. So my second derivative is 0. Then I want to my first derivative is 0. Now I want to take the second derivative of x. So that's just going to be negative 10 plus 18 x minus 2. What's that? 72? Doesn't really matter. So t prime prime of 2, this is going to go to 0, that's going to go to 0, I'm left with negative 10. Okay, very exciting. So, we know that f of 2 is going to be the same as t of 2, so f of 2 is 1, f prime of 2 is 0, f prime prime of 2 is negative 10, and this is just all based on the fundamentals of Taylor polynomials. That the Taylor polynomial is going to give you the same derivative values. That's what's all based on derivatives. Okay, so there's enough information to determine whether f has a critical point at x equals 2. There is, right? Because a critical point is just when the derivative is 0 or undefined. Well, we have 0, so therefore it is a critical point. And is f of 2 a maximum or a minimum? Well, since f prime prime of 2 is negative, therefore it is a maximum, right? So x equals 2 is a critical value since f prime of 2 is 0, and x equals 2 is a relative maximum since f prime of 2 is 0 and f prime prime of 2 is negative 10, which is less than 0.